So, in the last class, we were discussing about the structures and how an array of structures can be made, how structures can be passed into a function, as well as how structure can be returned from a function, etc. that we have seen. Now, in today's session, first we will see another data type, that is a union. So unions in C, that is today's first session, and if possible we will continue with some more topics, but first we will discuss about unions. So unions, it is a memory location that is used by several different variables of different types. That is, as in a structure, in a union you can define as well as you can declare a number of different variable types, different variables with different variable types. But the difference between the structure as well as the union is that in the structure, for each member in that particular structure, that is each element in that particular structure, separate memory location is stored. That is, if there are 5 different elements or 5 different members within a particular structure, so memory locations will be allotted for each of these 5 members separately. That is, an assignment to a particular memory location or memory location allocated to a particular member doesn't affect the storage of or the value that is being stored in another memory location, or another memory location in the sense another variable. But in the case of union, it is not the case. In the case of union, the same memory location is used by all the elements or all the members within that particular union. So the syntax of union is same as that of structures. The only difference is that in the case of structure definition, we use the keyword struct, but in the case of union, we use the keyword union. But the difference lies in the way in which the memory is allocated to different members in a structure as well as in the union. So that is the basic difference between a union and a structure. In the case of union, the same memory location is being used by all the members within that particular union, but in the case of structures, for each member separate memory location is allocated, or each member has its own memory location. So this is the definition. This is how a particular union can be defined. So instead of struct, we use union here. Union is the keyword that is being used for union. In the case of structure variable or structure type, we have to use the keyword struct. Then item will be the name of that particular type. So the item will be the union type. Then the double braces starts int m as well as char c. So there are only 2 types or data types in this particular union. That is limited in order to represent it as well as in order to explain it in a better way. So how to represent how the memory locations are allocated in a union. So in order to explain it better, we are using only 2 different types of variables in this particular union. So in this union, there is one integer variable, that is m, and one character variable, that is c, and an instance of that particular item is created, that is code. So union item, so instead of struct, it is union. So you know that if you use a struct keyword here, it will be a structure type, or structure type data type, a structure data type. But in the case here we are using a union, so this is a union data type. So union item, then the code is an instance or a variable of type item. So in code, the members m and c occupy the same memory location. That is the importance. The m as well as character c, the integer m as well as the character c will be occupying the same memory location in the case of a union. If it was a structure, it will be having separate memory spaces. That is, allocating some value into m doesn't affect the value that is being stored in c, or allocating a value assigning a value to C will not affect the value that is being stored in M. But it is not the case with the union. If we allocate some value into M, that will obviously affect the value that is being stored in C. And if we allocate some value into C, it will obviously allocate the affect the value that is being stored in M. So let us see how this comes up. So this is how the memory is allocated in the case of a union. So in the case of M is we know it is an integer type. An integer type in this case we consider that it takes 2 bytes memory space. So 2 bytes is allocated for the M. So there are 2 bytes, byte 0 as well as byte 1. So 2 bytes are allocated for the M type, that is the integer type, the variable M. M takes 2 bytes. But C needs only 1 byte. C is a character type. Since it is a character, it needs only 1 byte. So 1 byte of storage is, the first byte of storage is then allocated for C. So this will be the representation of the memory locations inside a union. So the total, if we read the total variable, the total space or allocated for this one, then it will be M, and the first byte or the first byte will be allocated to the character type. This is because we need 2 bytes to store an integer, and we need only 1 byte to store a character type. So the first, that is the byte 0, will be affecting any allocation to C will be affecting the byte 0. Since byte 0 is a part of the memory that is allocated to M, obviously that will also affect M. But on the other hand, if you allocate some value into M, it will be affecting the entire 2 bytes. Both the bytes will be affected by assigning some value into M. So that particular allocation or that particular thing will affect, that particular allocation will affect the byte 0 also. So that way it will be affect the C, the variable C will also be affected. So in the case of a union, the memory, the total memory that is stored for storing or reserved for storing a union type is the maximum memory that is required for any variable inside that particular union. So if it is an integer type, then the maximum data, that is the maximum storage space that is required to store an integer type will be reserved for that particular union, not more than that. Even if it contains, say, 5 different integer types, still data to store, the memory to store only one data item of integer will be reserved for storing a union type. But in the case of structure, we know if there are 5 different integer values or integer variables inside a structure, then obviously 5 into 2, that is 10 different bytes will be reserved for storing the data in that structure. So that is the main difference between structure and union. And now when a union is declared, the compiler allocates a memory location large enough to hold the largest variable type in the union. If the largest variable type is is of say a float type, so in that case the memory location that is allocated for the union will be large enough only to hold that particular floating point. If there is another floating point value, then obviously that if we assign a specific value to the next floating point value or floating point type, then this particular memory location will be rewritten, that is it will be overwritten. So that means only one variable can be stored inside a union. No other values can be stored inside a union. So all other elements within the union also utilize the same storage space. So thus the union offers a way for a section of memory to be treated as a variable of one type on one occasion and as a variable of a different type on another occasion. That is how it is being treated. That is, at one instance a particular memory location may be treated as integer type, and in the next instance it can be treated as a floating point if you are using a union. So the dot operator, as in the structure type itself, the dot operator can be used to access a union element as done in structures. So as in structure, how we use the dot operator to access the different elements or the different members within a structure. The same dot operator can be used in order to access the values or the variables within a union. So in a union, only one member can be accessed at a time. But in the case of structure, all the variables or all the members within that structure can be accessed at the same time. So we will not be able to access all member values at the same time in a union, because all members of union use the same storage space to hold the data, and that memory space or the storage space that is allocated to the union can hold only one type of data at a time. So that is actually a sort of disadvantage, but for high-end programmers this is a useful feature also. But structure can access all member values at the same time. Then structure allocates separate storage space for each of its members that we have already discussed. Then union or structure in C are based on the same concept that also we have said. It is the only difference in the declaration is the struct as well as union keywords, and reading the values from a structure as well as union is the same way itself, that is using the dot operator. The difference lies in allocating the memory for their different members. So now let's see a small example. Suppose in the previous case we have seen that we declared two members inside a union. The union of type was defined there, and then we created an instance of that particular item, the union item. Then that is code. Inside the code there is we know that m is an integer as well as c is another character variable that is available. So first we assign code dot m equal to 515. So this 515 converted into binary variable. You know that binary values are stored inside the memory location. So since there are 2 bytes for storing the value m, so it consists of 16 different locations, 8 for the first byte, that is byte 0, and another 8 for the byte 1. So the byte 0 is considered as the low byte, and the byte 1 is considered as the high byte. So when we are converting this into binary values, 515, when it is converted into binary values, it will be 1000000011. That will be the value. But when the value is being stored into the memory location, the last 8 positions or the last 8 locations will be stored into the first byte. So this is the way in which the data is being stored, or the integer value is being stored inside the memory location. So the first byte will be storing the last 8 positions. So 515, if we convert it into binary values, it will be like this: 1 0, then 0 0 0 0 0 0 1 1. So this will be the values. So the last 8 digits, 2 4 6 8, these 8 digits will be occupied by the first byte. So this first byte 0 0 0 0 0 0 1 1, so that occupies the first the last 8 bytes, and the rest 8 bytes is occupied by the high byte. So in the high byte, since it is only 1 0, the rest, all the 6 zeros will be inserted in front of this 1. So 0 0 0 0 0 0 1 0. So this is how a 515, a value of 515 is stored inside the memory location, and this total value is taken, or the total amount of memory that is allocated to that particular union is taken by the m variable. Now if we print n code c slash n code dot c percentage d code dot c. So if we print code dot c as an integer value, code dot c, we know that c is a character variable, but instead if we try to print it as a integer variable, so that is why it is percentage d represents integer. So code dot c is treated as an integer variable. So this code dot c, that c variable or the c element, will be taking only the first 8 bytes, I mean 8 positions, the first byte. So inside the first byte, the allocation is 0 0 0 0 0 0 1 1. If we convert this one into a decimal, it will be 3, since it is 1 1 in binary. 1 1 represents 3 in decimal. So what we will get on printing this particular line or displaying this particular line will be 3. And if we print the code m, code dot m, then obviously we will be getting 515, but c will be only 3. So that is the difficulty. When we assigned a value to m, it affected the value of in c also. Then if we assign, since c is a character, if we assign a character value to c, code dot c is equal to a. If we assign this one into c, the ASCII value corresponding to a is 65, that we know, and the value that is corresponding to a, that is corresponding to the ASCII value that is corresponding to a is 65, and the binary value that is corresponding to 65, that will be replacing the position here. The value corresponding to 65 will be the binary value that is corresponding to 65 will be replacing the positions, the values here. So what happens is, when again we try to print this code dot m, the value of m changes. The value of m changes in such a way that these 8 locations becomes the last and these 8 locations becomes the first. So the value that is assigned in that case to m will be 577. So let's see how is it right or not through a program. So a program for the same thing is created. Sorry, 1 second. Okay, here is the program for the same thing. We defined a union. Union is item, the name of the union is item, then it contains an integer m as well as a character c, and code is an instance of or a variable of the type item. Then into main void we assign code dot m as 515, as we described, or as we have seen in the presentation. The 515, the value 515 will be stored inside the 2 different bytes. Then printf slash n code dot c percentage d code dot c. So the code dot c is displayed or printed as a what you say an integer. So let's try how printing it as a character also, what it will represent. So what happens is the corresponding to 3, if there is a particular character, ASCII value 3 corresponding to ASCII value 3, if there is a character, that will be displayed. So what here we will be giving is percentage c, because it is a character that is to be printed. Then printf slash n code dot m percentage d code dot m. So the value of m will be printed here. Then we assign a value code dot c as capital A. So that is the ASCII value will be 65. So corresponding to 65, whatever binary value will be there, that will be replacing the first byte and thus we will get printing a code M that will give you 577. Okay, let's try it. Compiled, no error, C. This is how it will return. See, code.c, when it has taken as an integer value, it printed 3, and when it is taken as a character, it is shown some junk character. We cannot say that always it will be the heart symbol, but it is a junk, it can be a junk character. Then we printed the code.m, so it is 515. Then we assigned the code.c as a, so then we obtained the value of code.m as 577. So this is one of the difficulty with union, that is, if you change a value for a particular variable, that can change, or that will change the value for all other variables or all other elements inside that particular union. So that's okay. Another example of union I can show you another example where in this case the union, see, we start with the hash include stdio.h, then hash include string.h, since there is some string is to be displayed, so string.h, then hash define c underscore size is 25. So we defined the size as 25. This is just to show that the preprocessor directive, how to use the preprocessor directive define, hash define. So hash define c size 25. So whenever we use c underscore size, then always within this program always it will be equal to 25. So then we create a union address. The type of the union is union address, then the semicolon, the double braces, then char name c underscore size, char house c underscore size. So we know that c underscore size is 25. So this is same as a character array of size 25. Then char city and c underscore size, char state c underscore size, char pin code c underscore size. So all the five elements sorry, within this union address is of the same size. Each of them are character type or character array, that is string, and each string can contain up to 25 characters. Now we use this particular union inside a program. So int main union address person. So union is the type of the union is address. So union address person. So it is similar to the defining a structure variable, struct address person. It is similar to that one. Then printf, enter the name. We have to enter the name of the person. So it scans the value into person.name. Then we print the name of the name that we have entered, that is person.name. That will be printed. Then we display the message that enter the house name. The name of the house should be entered. Then it scans the value percentages person.house. Then it prints the value of the house name, that is what we have entered. Then in order to check whether the name of that particular person, the name that we have entered remains the same, so we print the person.name. The name value for that particular person is also printed then. And then we enter the city value. So it is same as displaying enter the city, then scanning of the person.city, then displaying the city value. Then in order to check whether the person, the name as well as house name of that particular person remains the same, we print the person.name as well as person.house. Then we scan then we enter the value for the state, the data for the state, then that is also printed. Then again we print the person.name, person.house as well as person.city. Then finally the pin code is entered, and then all the other four variables are displayed in order to check whether the values are varying or not. Since we know that since this is a union type, it holds for all the entire 5 variables or all the 5 elements within that particular union. The same memory location is being utilized. The same memory location is being utilized by all the 5 different elements within that particular union. So now let's try it, compiling it. Compiled with no error, then it is being run. So it is asking for a name. I am entering a name, say the name as Arun. So I entered the name Arun. So the name Arun, it shows the name as Arun. It displayed the name as Arun. Now I have to enter the house name, the name of the house that I have to enter. So I am entering number F-2 as the house name. So see, the house name is displayed as number.f-2, that is what I entered. But see the name I entered was Arun, but now the name is being shown as number.f-2. That is, whatever data I have entered last, that will be stored within the memory location that is allocated. That is, the same memory location is being used by the house name as well as name. Now I am trying to enter the city. Say it is Cochin. So I entered Cochin. See, all the city is Cochin, name is Cochin, and house name is Cochin. That is, all the 3 variables or all the 3 elements within that particular union is accessing the same data. Then enter the state. It is Kerala. So Kerala. See, state is Kerala, name is Kerala, house name is Kerala, and the city is also Kerala. So everything is Kerala. That is, the same data space is being utilized by all the different elements. Now it is the pin code 682308. So it is, see, all the values are 682308. That is, in the case of a union, memory is allocated to the largest element within that particular union. And if all the elements are of the same type, the same total memory location is being utilized by all the elements. So that is the difference between a structure as well as a union. In the case of a structure, for each element, separate memory is allocated, and each value can be accessed at any time. But in the case of a union, we can access only one value at a time, and the rest of the values will be overwritten. The last written value can be read in the case of a union. So that's about union, and I hope that's it. Then there is some other data types, that is the user defined data types. The user defined data types are the data types that is created by or that are created by the users itself. That is, a person can create his own data type. Actually, he cannot create a new data type, but he can rename the data types that is already available in C. So this is how it is being done. The C language allows users to define new data types that are equivalent to existing data types. So the only thing is, actually what we are doing is we are creating or we are renaming the existing data type into a new data type. That is it. So for that one, what we use is we use the keyword typedef. Typedef is used for this purpose, and the general form of usage is typedef data type new type. So data type is the data type that is available in C. This data type can be any data type that is available in C, including structure. So even if we use a structure data type, that can also be used here using the typedef. The new name, the new type can be a new name for that particular data type. So suppose we have created a data type of structure stud, stud, then typedef stud is student. Then from then onwards we can use student as the new data type. So in order to define a new variable of student type data type, you don't have to use the keyword struct again. In the case of structure definition, we know that if you want to create a new instance of that particular data type, that particular structure type, then you have to use the struct keyword. But in this case, if you are renaming it, or if you are creating a user defined data type, in that case you don't have to use the keyword struct. So let us see how it is being done. So in this case, typedef data type new type. So typedef is the keyword that is being used for creating the new data type, and this data type is any data type that is available with the C, that is any existing data type that is available in C. So once a new data type has been established, then the new variables, arrays, structures, etc. can be declared in terms of the new data type. So the new data types defined will be new in name only, as the type is not basically different from one of the standard data types. That is, actually what we are doing is we are only redefining the name, or we are only creating a new name for the existing data type. So this is useful when we are doing the structure definitions, or we are using the structure data types. So this is some of the cases, some of the user defined data types. So see, here is typedef int age. So we are using typedef, that is the keyword, in order to rename int as age. So any data type that is defined using age will be of type integer itself. So now if you want to create two variables a and b of type integer, then you can directly write it like this, age ab. So age ab. So now a and b will be of type integer, since it is written, the age is actually the basically age is of type integer. Now if we try this one, typedef float height 100. So height 100 is an array, height 100 is an array, and it is of type of float, and it is, the float is, or float data type is renamed with height 100. So if we create two variables, say men and women, two variables of type height. So height is the data type that is defined here, and height men and women, it will create two data types of type height, I mean two variables of type height. So the in this case the variables men and women are of type height, and height is equivalent to 100 element array of float. Height is equivalent to a 100 element array of float. So what happens is, in this case men will be having a 100 element array, as well as women will be having a 100 element array in which floating point values can be stored. So men will be a 100 element array, as well as women will also be a 100 element array, and in both these arrays a floating point values can be stored. And this is how the user defined data types are being used. The details, more details of user defined data types we will discuss probably in the next class.